This is our group's presentation on sustainability practices in construction and contracting.
Construction and contracting is a key industry in numerous countries for both employment as well as economic yield. Its yield is over 100 billion pounds a year and it represents 8% of gross domestic product, giving livelihood to around 3 million specialists on the planet. In any case, constructed structures are in charge of almost 50% of world's carbon emission, half of the country's water utilization, and records for around 33% of waste sent to landfill. In the course of recent years, the development business has gone under a lot of criticism as there has been a developing understanding that the present model of improvement is not supportable. Unfortunately, the environmental impacts caused by the construction activities are endangering. Annually, 70 million tons of wastes are produced and 50% of all energy generated is used by the industry. As an after effect of this, there has been gigantic drive towards promoting sustainable construction. The government has set out a dream to drive towards a feasible development industry. A joint commitment from the administration and the development business is to work towards a more reasonable development industry. The center points are to decrease the development business carbon impression and utilization of characteristic assets, and to make more secure and more grounded industry via preparing and holding a gifted submitted workforce. The vision is to structure and direct organizations to guarantee that structures and base are conveyed in a more asset effective and maintainable way. With expanding energy and waste costs, harder ecological enactment, expanded partner desires, significant associations inside the business are progressively focusing their endeavors on enhancing development practices to improve execution and show mindful conduct. It's imperative that contractual workers bridle the advantages of acting a practical way with specific end goal to wind up more effective associations and exploit the financial advantages, and in addition having a more positive impact on the earth and society by and large. So we will start with the pestle analysis of the industry. Ecosystem impact. The aggregated amount of adverse environmental impacts like waste, noise, dust and dangerous emanations still happen amid the development procedure, which cause serious harm to people and biological communities. Natural resources. Natural resources such as energy, land, materials and water are used in a typical construction process. Public impact. Most development tasks are situated in a thickly populated region. The construction environment can have both negative and positive effects on the occupants' nature of social life.
So, we will be talking about some initiatives in the field of construction and contracting. First is a zero carbon home. Single family dwellings with a very high efficiency rating are called zero carbon housing or zero energy housing. They require a very low amount of energy to provide for all the needs and activities of the families living in these homes. The yearly net carbon footprint of a zero carbon house is zero. The carbon footprint is the sum total of all greenhouse gas emitted directly or indirectly by activities in the home, such as room heating or operating an appliance, personal activities such as driving a car, broader services such as the use of public transportation or air travel, or individual consumption of food and other products. A home's carbon footprint is the sum of two parts, the primary footprint and the secondary footprint, which is expressed in terms of metric tons of carbon dioxide equivalent. The primary carbon footprint is a measure of carbon dioxide emitted due to direct utilization of fossil fuels for consumption and transportation, and the secondary carbon footprint is the measure of indirect carbon dioxide emitted due to manufacturing processes of appliances used in the house and their natural decomposition. Determining a zero carbon home. Energy efficiency. To be a zero carbon home, they have to be efficient in the utilization of energy and also minimize the daily demand of energy. New homes are required to install sufficient insulation and also be adequately airtight. Carbon compliance. To reduce the on-site consumption of carbon technologies which promote low on-site carbon usage and zero carbon energy such as community heating network should be used. The system of a community heating network or district heating distributes heat for residential heating and commercial water and space heating needs from a central location. This substantially reduces the carbon footprint of individual homes. Allowable solutions. Some of the numerous types of approved carbon saving measures that could be used on homes consist of on site, near site, and off site options. On site options include the installation of smart devices, use of grid injected biomethane, installation of site based heat storage, etc. Near site options include local micro hydro schemes, communal waste management solutions, and local energy storage solutions. Off-site options include investing in plants that turn waste into energy, investing in renovating houses with low carbon technologies, and investing in low carbon cooling, etc. Private companies and government organizations are beginning to promote zero carbon homes and zero carbon footprints. In the United Kingdom, the Zero Carbon Hub helped the construction of zero carbon housing and converted it into a more common practice. The Zero Carbon Hub was a public-private partnership to help reach the government's energy consumption reduction goals set by the European Union under the Kyoto Protocol of 1997. Earthship Biotecture. An example of a zero-carbon housing is the Earthship Biotecture. It was developed by Mike Reynolds. The Earthship is an environmentally friendly and completely sustainable home that can be built anywhere in the world. They are constructed with materials that are normally discarded and take up space in a landfill. This includes old tires, bottles, and cans. Reynolds has three requirements for Earthships. 1. A sustainable architecture using natural and/or artificial materials should be utilized. Second, the house should be dependent on natural off-grid energy sources. Third, the house has to be financially feasible and must consist of a DIY concept so that the average person can also build their own Earthship.
When we talk of sustainability initiatives, we surely look at the concepts of green building. Green building refers to both the structure and using of processes that are environmentally responsible and resource efficient throughout a building's life cycle. Green building practice expands and complements the classical building designs of economy, utility, durability, and comfort. There are various ratings attributed to green buildings, important ones being LEED and BREEAM. Leadership in Energy and Environmental Design (LEED) is a set of rating systems for the design, construction, operation, and maintenance of green buildings, which was developed by US Green Building Council. BREEAM stands for Building Research Establishment Environmental Assessment Method. The main objectives of a green home are as follows: efficiently using energy, water, and other resources in an optimum manner, protecting occupant health and improving employee productivity. And the second and the last one is reducing waste, pollution, and environmental degradation. As we see in the diagram, that it involves two visions. The first vision is a short term and the second one is a long term. So the first step is to look at the short term and then look for a longer vision. Short term includes greenhouse enhanced by insulation using materials available in the markets to insulate the outside wall of a house. Long-term characteristics of greenhousing include recycling of water as a facility in the house, natural ventilation, whole house ventilation with heat recovery along with a solar roof on top to harness energy. According to the two scientists, Dakin and Weirlist, there are four factors that define the smart cities. The first one is application of a wide range of electronic and digital technologies to communities and cities. The famous example that we have right now is Bhubaneswar being a smart city. Second we come is to the use of ICT to transform life and working environments within that region. Third one is embedding of information and communication technologies in governance systems. And the last but not the least is the territorialization of practices that brings information communication technologies and people together to enhance innovation and the knowledge that they offer to. Now looking at the role of information technology in smart city, we find the following points useful. The first is to utilize physical infrastructure more efficiently. Second, collaborate with locals in governance and decision-making process. And finally, learn, adopt and innovate, thereby responding to changing circumstances. These forms of intelligence in smart cities are defined in three ways. The first one is orchestration intelligence. It is defined as a type of intelligence in which smart cities establish institutions and communities based on problem solving and collaboration. The second type of smart cities intelligence is empowerment intelligence. The cities that provide open platforms, experimental facilities and smart city infrastructure in order to cluster innovation in certain districts. classifying the whole area into small districts and then providing innovations in the form of a cluster. The third point is instrumentation intelligence, in which city infrastructure is made smart through real-time data collection with analysis and predictive modeling techniques across city districts.
Some of the impacts can be as follows. One of the key innovations in construction is to create an alliance between the different stakeholders. Unlike traditional forms of contract where risk is allocated to different parties, under a true project alliance, the alliance participants take collective ownership of all risk associated with delivery of the project. It results in a save in overall project cost and delivery time. Point number 2. Drone technology has been implemented in some parts of the construction industry. When it comes to surveying potential construction sites and monitoring active sites, these drones are literally changing the construction landscape. It helps in monitoring workers and performs a quick survey of a particular construction site. Point number 3. The mobile apps are ubiquitous. The presence of such apps in the construction industry has definitely changed the perspective of the leaders in this industry. Construction apps allow foremen and contractors to get the most out of their gadgets. There are also calculating apps that help construction managers better calculate supplies, including concrete volumes, roofing materials, and hardware amounts. Point number 4. The identified challenges in the implementation of construction innovation include degree of uncertainty, cost savings generation, minimizing the environment impact of its consumption of materials, and elimination of waste by removal of all non-value adding activities. These are some of the problems that can be solved with proper initiatives and innovative practices. It is also recommended that the construction workers or the professionals operating in this industry follow a very comprehensive policy.
Awards and recognition. Lafarge Holcim Awards. Based on this concept, to make sustainable construction easier to understand, evaluate and apply, the Lafarge Holcim Foundation and its partner universities have identified a set of 5 target issues for sustainable construction, which serve as the basis for the adjudication process of the Lafarge Holcim Awards and as a framework for the activities of the foundation. Innovation and transferability. Progress. Projects must demonstrate innovative approaches to sustainable development, pushing the envelope of practice and exploring new disciplinary frontiers. Breakthroughs and trend-setting discoveries must be transferable to a range of other applications. Ethical standards and social inclusion. People. Projects must adhere to the highest ethical standards and promote social inclusion at all the stages of construction, from planning and building to use and servicing, to ensure an enduring positive impact on communities. Proposals must demonstrate how they enhance the collective value, resources, and environmental performance. Planet. Projects must exhibit a sensible use and management of natural resources throughout the entire life cycle. Long-term environmental concerns, especially pertaining to stocks and flows of material and energy, should be an integral part of the design philosophy. Economic viability and compatibility. Prosperity. Projects must prove to be economically feasible with regard to channeling and managing financial flows, promoting an economy of means, and be compatible with demands across the construction's lifespan. Contextual and aesthetic impact. Projects must convey a high standard of architectural quality as a prevalent form of cultural expression, with space, form, and aesthetic impact of utmost significance. The material manifestation of the design must make a positive and lasting contribution to the physical, human, and cultural environment. Conclusion. The construction sector is central to the overall economy of many developing nations, accounting for more than 10% of the GDP in case of European Union nations, providing accommodation and infrastructure and playing a prominent role in the global marketplace. Continued research and development is vital to provide a sound basis for recovery from the effects of economic downturn and to address the global problems of climate change and population growth. By taking innovative approaches to the development and application of building and infrastructural technologies, a viable future for the construction industry can be ensured, as a result of which the well-being of every citizen can be easily ensured.